Hello friends, MoNaCo here with our second homework video for atomic theory. We're going to focus about the subatomic particles today, and we're really going to start interpreting the periodic table. Everyone knows what the periodic table is, but you're going to start to dig deep and understand all the information on a single tile in the periodic table, what it means for protons, neutrons, electrons in an element. So you're going to understand those basics here today. So this is a very, very important video. You may have to watch it a few times just to make sure that you've got this stuff, because if you don't understand these concepts about subatomic particles, you're going to be kind of out in the weeds there in the next few videos. So make sure you are good at this stuff. All right. What information is hiding in a square on the periodic table? Okay, see down there, there's a nice Photoshop version of a helium tile, and it's got a bunch of, well, numbers in it. I mean, He, that's a symbol. Helium, that's the name. We know about that. We did a quiz on that. But what does the other stuff mean? It's a code, and I'm going to teach you how to understand that code. So make sure that you've got this stuff, because you're going to have to interpret these tiles for the rest of the course. All right. So the first thing first, this is an interpretation of the key on the periodic table. There is a key on your periodic table that says atomic mass, okay, and it points to this number up in the left-hand corner. But what is atomic mass? It is the average mass of all the isotopes of an element, okay, and there's a key that has a number pointing here, and it says atomic number. But what is the atomic number? It's the number of protons in every atom of the element. That's very important to know. So the big bold number in the bottom is the atomic number. And guess what? There's a key on your periodic table, so don't forget to look at it if you forget. Top right corner, oxidation numbers. On your periodic table, it says selected oxidation states, but it's the same thing. And what does it mean? It's the possible charges an atom of an element can have. More on that later. Well, the element symbol, we know those pretty well, but our periodic table does not have the names on it, so you have to know your symbols so you can be fluent with your names. Last, certainly not least, probably the most important part for chemical reactivity and actual chemistry is this number, the electron configuration. What is that? It's the number of electrons in each energy level, i.e. orbital, and you add all the numbers in that sequence. That's not 2 minus 4, that's 2 dash 4, 2 then 4. You add all those up to figure out the total number of electrons in a neutral atom of any given element. Okay? So there's some subatomic particles out there. One of the modern models of the atom shows that there's electrons, protons, and neutrons. So a proton has a charge of +1. Why? Well, because we assigned it a charge of +1 through our experimentations. It has a relative mass of 1 AMU. What do you think? What's an AMU? It's an atomic mass unit. So we defined a proton as being 1 AMU. You find your protons in the nucleus of the atom. That's a small, dense core. It has some symbols you might see, like a P or a 1P1. Okay? More on that later. And you have to look at the atomic number in order to figure it out. So if you're asked, how many protons are in carbon? You go look at the atomic number. It is the atomic number, and that is your answer. A neutron. This was the last subatomic particle that was discovered, and it has no charge. It didn't bend in a cathode ray tube experiment. It didn't bounce off the nucleus. It was not charged at all. It was hard to find, but we defined it as having 1 AMU. That was discovered, honestly, in the 1930s. They're found in the nucleus as well. It was why they were hidden. Didn't know they were there until, well, the Manhattan Project, when we started studying radioactivity. Symbols are N for neutron and 1N0. The bottom number down here is the charge. Notice the charge is 0 and the bottom number is 0. Okay? Not a coincidence. How do you figure out the neutrons? You take your atomic mass number and you subtract your atomic number. Okay? Electrons, J.J. Thomson, good old guy with the cathode ray tube, he assigned it a charge of -1, and it was so small that it has almost a negligible mass. It does not weigh much anything compared to the protons and neutrons, but they are on the outside of the atom, which is where all the chemistry happens, which is why they were discovered first. E negative or E is the symbol that we commonly use for electron. I use E negative all the time, so don't get confused when I see that. How to calculate electrons? Well, the protons equal the electrons in a neutral atom. Know it. Moving on. Some other symbols used in nuclear chemistry. Well, this is nuclear chemistry, but these symbols are very important throughout the entire course. Mass number is the sum of the protons and neutrons, so P plus N equals mass number. The nuclear charge, it's the charge inside the nucleus, so it's always positive, and it's the number of protons. Nucleons, that's just a fancy name for any particles found in the nucleus. Basically, it's just protons and neutrons. Nucleons, protons, and neutrons. Okay. Moving on, we had a little bit of practice. Okay, so I've got my periodic table, and I know my subatomic particles very, very well. So what I'm going to look for is how to fill out the rest of this chart. If I see here, number of protons, I'm going to start there. Number of protons, this element has 15 protons. So what do I look for? I look for the atomic number 15. And I write it right here. P for phosphorus. Okay. Number of neutrons, well, 16. So 15 plus 16 is 31. So I can say that's 31 after the phosphorus. Protons always equals electrons, so I can fill that out. That's 15. The atomic number is the same as the protons, so that's 15. The mass number, well, that's the number of neutrons plus the protons. That's how I got the 31 there. Nuclear charge, the charge of the particles that are in the nucleus. Oh, it's protons that are in the nucleus. There's 15 of them, so I'm going to say plus 15, just to distinguish that this is protons. The nuclear symbol that you would write would be something like this. P for phosphorus. On the top, you put the atomic mass, 31. And on the bottom, you put the atomic number, 15. Okay? So as you go through the rest of these, you can start to fill in pieces of information that you've been given. C14. So I know that's carbon, and it weighs 14. I know it's got 8 neutrons. If I look at my periodic table and find carbon, I can see it's got an atomic number of 6, which is the same as the protons. Okay, now I can start filling in little more pieces of information inside the chart based upon that little scavenger hunt that I'm doing. Carbon 14, because that's the number on the top. Number of electrons is the same as protons. That's 6. Okay, so you need your periodic table. And you need to know your numbers and your facts and your definitions in order to complete this chart. Practice, practice, practice makes perfect, perfect, perfect. So let us get to the end of this. You should now be able to determine the number of protons, neutrons, and electrons in an atom of any given element or particle. I know I went through the chart quickly, but you have to go and study and memorize these things. Otherwise, you will not be competent at this very basic and very important skill in chemistry. So appreciate it, watch it, rewatch it, know it, know it, know it. There's plenty of practice to do in class, or if you're competent, go ahead and do it on your own. Thanks, everybody. See you in class.